Hello there, Algebra 2B, and welcome to Lesson 7.2. This is day one, or the first part of our notes here, and it's going to start out with a review of the properties of exponents. And really, we're going to tie these in with fractional exponents. So, remember, if you have the same base and two different exponents, you add the exponent. So this is going to become the same base, m plus n. In the past, we did something like if you had 5 squared times 5 to the third, that would be 5 to the fifth. Same idea if you had negatives, negative 2 to the sixth times quantity negative 2 to the third, that would be negative 2 to the ninth. What we're going to do today is basically the same thing, but with fractions. So if you have 5 to the 1/5 times 5 to the 1/6, you can add together those exponents. Now, I know fractions are something that are a bit scarier, but fortunately, your graphing calculator can add fractions for you if they are something that causes you problems. So 1/5 plus 1/6, and that is how you can enter fractions into your calculator. It's going to be 0.36. Make sure you make that another fraction, and we would have 5 to the 11/30ths. Okay, that's really the main idea. Fractions, just add them together. Also remember properties, power to a power property. This is when you multiply. You multiply the two together. If you see parentheses, that's when you multiply. Sometimes students forget when you add and when you multiply. For example, in the past, if we had 5 squared to the third power, this would be 5 to the sixth. Similarly, same with negatives, negative 2 to the third power, even if it's a bracket, something like this, that would then be negative 2 to the sixth. Okay? For fractions, for today's stuff, basically, if we have 3 to the 1/2, and we raise that to something like the third, when you multiply fractions, remember it's just the numerator times the numerator, essentially, and this would be 3 to the 3/2. Similarly, if we had negative 4 to the 1/2, all to the fifth, that would be quantity negative 4, all to the 5/2. One more just to clarify some things here. 5 to the 1/2 to the 3/2 power. When you multiply fractions, again, numerator goes to numerator, denominator to denominator. So this is just going to be 5 to the 3/4. Okay, so fractions, don't be afraid of those with multiplying either. Similarly, again, distributing exponents to a quantity property of powers, you just have to make sure you distribute to both things. This is important whenever there's two different bases. Say we had 5 squared times 6 to the third, all raised to the second power. This would then become 5 to the fourth, distribute and multiply, times 6 to the sixth. You would be done at this point, okay? You can't combine those bases in any way. You'd be done right there. If you had 5 to the 1/2 times 6 to the 1/3, once again, let's take it to the 2/3 power. With our fractions, you're going to distribute, and that would become 5 to the 2/6, and also times 6 to the 2/9. What you can actually do is, if you notice how 2/6 can reduce, we could make this 5 to the 1/3 times 6 to the 2/9. Okay, you don't want to combine those in any way. Don't worry about, oh, this is a 9, this is a 3, we could add those somehow. Just leave that as your answer. That's all I'll be looking for. Okay, so we're just applying these properties to fractional exponents. Where it gets a little trickier is remembering negative exponents. Negative exponents do not mean negative numbers. So not negative numbers. Instead, they move it to the bottom, okay, in which it becomes positive. So if we had 7 to the negative third, that's the same thing as 1 over 7 to the third. Similarly, if we had 1 over 3 to the negative 2, that goes up and becomes a 3 squared. You don't have to put over 1, but to show the process, that's essentially what it would be. With fractions, it's really the same idea. 7 to the 1/3, that's negative, is not going to be negative 7 1/3. It is going to be 1 over 7 to the positive 1/3. That's really it. Nothing else fancy going on there. If you had 1 over 3 to the negative fifth, 5 halves perhaps, okay, that's just going to come up 3 to the positive 5 halves. Okay, so just know the difference between negative numbers and negative exponents. They are not really related. Okay, subtraction is what occurs when you have the same base and you have different powers on top of one another. So you're going to subtract the two powers. Okay, in the past, when we had 5 to the 6th, all over 5 to the 3rd, it's the same thing as taking 5 to the 6th minus 3, which is simply 5 to the 3rd power. Okay, with fractions, it's really the same idea. 3 to the 1/2, all over, whoops, that's a wonky fraction bar there, all over 3 to, let's say, the 1/4, it would be 3 1/2 minus 1/4. Do that in your calculator if you'd have to. 1/2 minus 1/4 would be 0.25. Make it another fraction, and that's going to be 1/4. Where it gets tricky is if the numerator is a little smaller. So let's consider 3 to the 1/2 all over 3 to the 3/4. In this case, I would say still do 1/2 minus 3/4. Okay, what that would become, use your calculator. We see it's going to be a negative 1/4, which is then going to move it in the denominator of a fraction. So if you get a negative after subtracting, just kick that downstairs and you're good to go from there. So subtraction with some fractions there. Our final property to recall is division, but distributing the exponent. So a to the m all over b to the m. We're going to dive into a fraction property here. If we had 5 to the 1/2 all over 7 to just the second even, and we distribute that to the 3/4. Okay, what that's going to become is 5 to the 3/8 all over 7. This is really a 2 over 1, so 6/4. And if you simplified that, 5 to the 3/8 all over 7 to the 3/2. Okay, so don't be afraid. If you have something funky, maybe it's 5 to the 1/2 all over 7 to the negative 1/2. And we are going to distribute that with another 1/2. Okay, different ways to go about this, but I would just go ahead, distribute that 1/2, and multiply. So 5 to the 1/4 all over 7 to the negative 1/4. Negative exponents you want to get rid of, so that's going to go upstairs. The 5 to the 1/4 is still up there, times 7 to the 1/4, and you would stop there as your answer. So all those things, as you can imagine, we're going to combine them in a little bit, but those properties all apply to fractions as well. Pause if you need to, get those examples down, and then we'll get into some more challenging problems. So simplify the expression, write your answers using exponents. Really, this is just some more practice of those properties we just did. So remember, same base, multiplication, you just add. So 7 1/4 plus 1/2. If you also want to think, if you want to try some of these in your head, it's really 7 plus 2/4. You have to have the same denominator to add them. So that's 7 to the 3/4, and you're done. Next problem. What do? We distribute the power of 2. So 6 to the 2 over 2 times 4 to the 2 over 3. 6 to the 2 over 2 is really just 6 to the 1. You don't even have to write that one if you don't want to. And times 4 to the 2/3. Both those things separate in that case. Answer right there. Okay. Moving on, let's see what this one brings. Okay, a little bit of funkiness with this one. So let's check this out. 5 times negative 1/5 is going to be negative 5 over 5 times 3 to the negative 5 over 5. Now, what that really means is 4 to the negative 1 times 3 to the negative 1. And negative exponents, okay, you need to kick down to the bottom of a fraction. So 1 over 4 times 1 over 3. In this particular case, since there's no other exponents, if you wanted to make that 1 over 12, you could. You can only do that if the exponents are both 1 in this case to multiply. So the main thing is that you would get to this middle point here. But then if you want to multiply further, you can. Let's check out this one. So don't forget there's an imaginary 1 with a 5. So that is going to be 5, 1 minus a third. 1 minus a third is going to be 5 to the 2/3, sorry. I know I might be going quick, but that's why you can always pause and go back and write again. So 5 to the 2/3, and you're done. Okay? Just a few more examples will get you practicing. This one has a fun trick. Fun trick. Yeah. If you notice that your exponents are the same, what you can imagine is happening here is we are taking 42 over 6, and we can almost undistribute to 1/3. We would still have the 2 outside. With that being done, you can actually divide the 42 and the 6. So 42 over 6 is 7. We're still going to have the 1/3 to the second. And all that becomes is 7 to the 2/3. Okay, that only works if the exponents are exactly the same on those numbers. So in this next example, unfortunately, it's not quite as fun. You cannot do the little trick. So you just have to go right ahead and distribute the 4. So 30 to the 4/5 all over 5 to the 8/3. And that's what it would be. I know it's tempting. You're like, oh, but 30 and 5, they divide so nicely. But you cannot do it because they're not the same exponent. Okay? So just trust that is your answer here. Okay? 2 more. I invite you, if you want to take on the challenge yourself, you can. I'll go through them. We're going to distribute. See if anything fancy happens. 2/15. 2/20. Only fancy stuff is 7 to the 1/10. 5 to the 2/15. Okay. Last example. This one. Can we do the trick? Same. Yes, we can. It's a fun one. So 20 over 5 is 4. You would still have the 1/2, and you're going to distribute that with a third. So 4 to the 3/2. Bada bing, bada boom. All right. No, I went quick, but wanted to make sure you got that in. And again, pause, go back, write those down, practice out the problems attached. You should be in good shape. Good stuff, guys.